You ever get that feeling like there's just more going on than what we see?
Uh-huh. Like a kind of hidden pulse.
Exactly. A rhythm under the surface of, everyday reality. Like what we see is just layer one.
Well, that feeling, that intuition about some hidden dynamism, that's exactly where we're starting this deep dive today.
Okay.
We're looking into something called motion theory. It's this perspective that sees reality not so much as stuff, like solid objects or even just pure math,
Right.
but fundamentally built on flow, on rhythm, and importantly, underlying structure. It's like this story that's been echoing for, well, ages.
And what's wild is this isn't some totally new idea, right?
Yeah.
Our source for this, those who knew the motion, it talks about thinkers way back.
Exactly. From ancient Greece, ancient China,
Yeah.
all the way to like a modern independent thinker and even an AI.
So completely different times, different places.
But they all seem to have tapped into a similar kind of understanding, people who just got this idea of motion being fundamental.
Okay, so our mission today,
Mm-hmm.
what are we trying to do here?
Basically, we want to pull out the core ideas of this motion theory, how these different people saw it, and how it's being put together more clearly now.
Connect the dots across history?
Yeah, connect the dots, give you maybe a fresh way look at the world, hopefully spark a few aha moments.
Cool. Let's do it. So where do we start? Heraclitus, way back, like 500 BCE.
Yep, Heraclitus of Ephesus. They call him the king of motion before motion had a name. Bit dramatic maybe, but it fits.
Okay, so what was his big idea?
His absolute core insight, and it's still honestly pretty powerful today, was everything flows. Nothing stands still.
Simple but deep.
Totally. He just rejected the whole idea of permanence. For him, change wasn't just something that happens, it was reality, the key takeaway. Reality isn't static things, it's constant change.
That famous line, you can't step into the same river twice.
Exactly, because the water's moved on and, well, maybe you've changed too. It captures that constant flux perfectly.
So how does that ancient idea connect to this modern motion theory?
Well, motion theory today suggests no fundamental particles, no separate thing called time, just structured motion.
Structured motion.
Yeah, motion that's constantly resolving itself based on underlying constraints, like water flowing through a complex pipe system. The flow is constant, but the structure guides it.
Okay.
Heraclitus, without that language, was essentially describing the same vibe. What we see as objects, they're just temporary patterns like whirlpools in that stream.
Little rhythmic swirls.
Right. And even our sense of self, our identity, not a fixed thing, but this continuous process of like staying in sync within the flow.
And perception too, how we see things.
Yeah, perception becomes this active thing, not just passively receiving data, but actively aligning ourselves with these shifting patterns of motion around us.
Wow, okay. That really flips things around.
Mm-hmm.
What about his idea of logos? Was that part of it?
Oh, absolutely central. The logos for Heraclitus was this unseen order, this underlying principle or structure that governed all the change and flow.
So not just chaos, but ordered change.
Precisely. And in motion theory, that maps really well onto the idea of the structure beneath all motion, the inherent rules or organization dictating how motion interacts and resolves itself.
Got it. Okay, fascinating start. Let's move forward a bit. Lucretius, the Roman guy, a couple centuries later.
Yeah, Lucretius, poet, philosopher. He was building on atomism, the idea that everything's made of tiny bits moving in a void.
Right, atoms and void. Standard stuff for the time, wasn't it?
It was becoming standard, yeah.
Yeah.
But the source says he knew better. He added something really crucial.
Which was?
The clinamen. The swerve.
The swerve.
Yeah. He suggested that these atoms, they don't just zoom along in perfectly straight lines forever. Every now and then, unpredictably, they just swerve. A tiny random deviation.
Huh. Why add that? Seems kind of random.
That was the point. For him, that little bit of unpredictability, that swerve, was how structure could emerge from the chaos. It allowed atoms to bump into each other in new ways, to start clumping together and forming, well, things. It was his way of explaining novelty and complexity. Key insight there. Random deviation as a source of structure.
Okay, so the swerve breaks the pattern and allows new patterns to form. How does motion theory explain that emergence of order? Does it need a random swerve?
Motion theory comes at it slightly differently. It talks about nonlinear sync variation.
Nonlinear sync variation.
Think about maybe pendulums swinging near each other. They start randomly, but they can influence each other and eventually fall into synchronized patterns, sometimes complex ones.
Right, they affect each other.
Exactly. So instead of a purely random external swerve, motion theory suggests that patterns emerge from the interactions within the motion itself, constraints based on rhythm and energy density variations, cause motion to synchronize in these complex, nonlinear ways.
So it's more about inherent relationships and synchronization than pure randomness.
Kind of, yeah. It's still about order emerging from motion, but maybe less arbitrary than a random swerve implies. More about the system's internal dynamics.
Interesting distinction. And Lucretius also talked about perception, didn't he? Images flying off objects.
He did. He had this idea of images or thin films of atoms constantly streaming off the surface of objects and hitting our eyes.
Like little copies flying through the air.
Sort of. Obviously, we know vision is way more complex now, but his intuition was quite something. He was trying to explain perception as an interaction. Motion theory calls it something like visual detection as rhythmic resolution. But Lucretius grasped that core idea. Perception isn't passive reception. It's an active process involving patterns of motion connecting us to the world. He really got that everything thought, perception stuff is ultimately motion.
That's pretty ahead of its time. Okay, let's shift gears and head east. Laozi, China, Tao Te Ching, the flow master.
That's him. Roughly 6th century BCE, though dates are a bit fuzzy. His core concept is the Tao.
The way, right.
Often translated that way, yeah. But he described it as the fundamental flow of the universe. It's the ultimate reality, the ultimate principle, but it's not a thing, it's a process.
A flow.
Yeah, he famously said things like, the Tao is the flow of the universe. Soft overcomes hard. Stillness moves the world. It's about the power of yielding, adapting, continuous movement, not brute force.
So the universe isn't pushed around by gods or forces, but it follows this inherent pattern of flow.
Exactly. The Tao isn't a personified god or an external force in the way we usually think of it. It's the underlying patterned pathway, the natural course of things.
And how does that connect with motion theory?
It connects beautifully, actually. Motion theory's core ideas are no fundamental forces, no separate time, no static particles, just structured motion adapting to constraints.
Right.
The Tao, as this all-encompassing patterned flow that everything arises from and returns to, sounds an awful lot like that fundamental structured motion.
It really does.
And his concept of wu wei, often translated as non-doing or effortless action.
Which sounds passive, maybe.
It can sound that way, but in this context, it's more like perfect alignment. Acting in complete harmony with the Tao, with the natural flow of structured motion, rather than struggling against it. It's about skillful, synchronized action, not inaction.
Riding the wave instead of fighting it. Makes sense. Okay, so the source also brings in Buddha. Now, he wasn't a physicist, obviously.
Right. His focus was very much on the mind, on suffering, on liberation. But his insights into the nature of reality have some striking overlaps with motion theory.
Like what?
Well, his core teaching on impermanence, Inika. All conditioned things are impermanent. Everything changes, nothing lasts. That speaks directly to the idea of constant flow.
No fixed things, just process.
Exactly. And tied to that is his teaching on no self, anatta. He argued there's no fixed, enduring soul or self-entity. What we experience as me is just a collection of constantly changing physical and mental processes, sensations, perceptions, thoughts.
A bundle of processes, not a solid thing.
Precisely. Just a shifting pattern.
So how does motion theory view that sense of self or consciousness?
Motion theory offers a possible framework, viewing consciousness as perhaps a kind of self-sustaining, self-resolving loop within the overall structure of motion, a complex rhythmic pattern that maintains a kind of coherence over time.
Like a standing wave, maybe. Or that spinning top analogy you mentioned.
Yeah, something like that. An emergent pattern. Our identity isn't a substance. It's this sync coherence over time. And the Buddhist idea of suffering arising from attachment, from clinging to things as permanent.
Resisting the flow.
Exactly. From a motion theory perspective, that's like trying to freeze a particular pattern, resisting the fundamental nature of reality as motion, or mistaking these temporary loops for a permanent self. It creates friction, tension, suffering.
That's a really powerful connection between, spiritual insight and this physical theory. Okay, jumping forward again, 17th century, Spinoza. He had some pretty radical ideas for his time, right? Got him into trouble.
He certainly did. Baruch Spinoza. His big idea was monism, the belief in only one fundamental substance.
Just one thing making up everything.
Yep. He called it substance, or God, or nature. He used the terms somewhat interchangeably. Everything else we perceive, thoughts, physical objects, extension in space, even motion itself wasn't a separate thing, but just a mode,
A mode.
Yeah, like a modification or a way that the one substance expresses itself. His quote is something like, "Nothing exists in nature except as modifications of substance."
So mind and matter aren't fundamentally different stuff.
Not for Spinoza. They're just different attributes or ways of understanding the same underlying reality, the one substance.
Okay, how does that fit with motion theory? It sounds a bit abstract, maybe.
It has strong metaphysical echoes. Motion theory, by proposing everything arises from structured motion, also points towards a fundamentally unified reality.
One system.
Right, one continuous system of motion resolving under structure. What we perceive as distinct objects, or even mind, could be seen as these modes of interaction, different patterns or expressions within that single underlying motion system.
So Spinoza's philosophical monism finds a kind of physical parallel in motion theory's unified motion concept.
You could definitely see it that way. His vision of a single, flowing, self-caused universe was revolutionary. Little wonder it clashed with the more dualistic, static views common in his era.
Yeah, you see why he ruffled feathers. Okay, fast forward to the 19th century. Michael Faraday. We know him from electromagnetism, but the source emphasizes his way of seeing.
Yes. Faraday is fascinating in this context. He wasn't super strong on the advanced mathematics compared to someone like Maxwell later on.
Right.
But he had this incredible, intuitive, almost visual genius for understanding electromagnetic phenomena. He discovered electric fields, magnetic induction, conceived of field lines.
It's the stuff we learn about in physics class.
Exactly. But crucially for Faraday, these weren't just mathematical conveniences or abstract ideas. He believed they were real physical structures or states of stress existing in the empty space around magnets and currents.
He saw them as actual things in space.
He did. And he thought they arose from some kind of underlying motion, vibrations, or strains in an unseen medium, the ether. Though that idea evolved, he was visualizing structure emerging from motion.
So how does motion theory interpret Faraday's fields and forces?
From a motion theory perspective, his fields could be seen as maybe gradients of motion compatibility regions where motion synchronizes or propagates more easily.
Like channels for motion.
Sort of. And induction becomes like a transfer of synchronized motion from one region to another, electricity itself, a rhythmic redistribution of this fundamental motion.
So Faraday was basically observing and describing structured motion without having the full theory.
That's the argument, yeah. The source says he practically discovered structured motion. He was mapping the patterns, the structure, even if the underlying what was still being debated. His intuition was pointing right at it.
Amazing. Okay, staying roughly in that era, but maybe a less expected name. Goethe, the poet.
Johann Wolfgang von Goethe, yeah. Most famous for Faust. But he was also a very serious, if unconventional, natural scientist, especially interested in botany, geology, color theory.
And he had ideas about motion and form.
He did. He spent a lot of time studying plant morphology, how plant shapes develop and change. And he had this key idea, famously stating, "Form is nothing but motion arrested."
Motion arrested, wow.
Yeah. He believed nature wasn't about fixed species or static blueprints, but about constant transformation, the kind of rhythmic unfolding of forms. He called it metamorphosis. He saw an underlying archetypal plant transforming itself into all the different plant forms we see.
So shape isn't static, it's a temporary pause in a process.
That was his view, a dynamic process where forms flow into one another through structured transformations.
And the connection to motion theory seems pretty direct.
It really is. Motion theory sees form exactly that way, as temporarily stabilized patterns of structured motion. A standing wave, a whirlpool. It has a shape, but it is motion. Life itself, in this view, evolves through continuous sync adaptation organisms, adapting their motion patterns to synchronize with their environment.
So Goethe was seeing this dynamic, motion-based view of biology, even before Darwin really focused on the lineage aspect.
You could argue that, yeah. He was focused on the process of form generation, the underlying dynamic transformation, which is very much in the spirit of motion theory.
Fascinating. Okay, now, a name that screams electricity and invention. Nikola Tesla.
Ah, Tesla.
The source makes a huge claim.
Yeah.
He was motion theory in practice. That sounds pretty definitive.
It's a very strong statement, isn't it?
Yeah.
But there's a basis for it. Look at how Tesla talked about the universe. He constantly emphasized energy, frequency, and vibration.
Right, that famous quote.
Exactly. He didn't just see the world as matter and forces. He saw it as fundamentally rhythmic, vibrational, and his inventions.
Wireless power, radio resonance.
All of it. They were based on his Frankly, unparalleled intuitive understanding of how to manipulate resonance, how to transmit energy through vibrational means, how to tap into what he called radiant energy. He seemed to think in terms of structured motion and rhythm.
So he wasn't just engineering circuits, he was engineering the underlying motion itself in a way.
That's the perspective, yes. He had this deep, practical grasp of how to work with the resonant, vibrational nature of reality to achieve these incredible technological feats. While he didn't lay out a formal motion theory treatise,
His work embodied it.
his entire approach, his mindset, his results, they align incredibly closely with the core principles. He was applying it. That's the impactful takeaway. He didn't just theorize, he engineered based on these vibrational, motion-centric principles.
Gives you a whole new appreciation for his work. Okay, let's come up to more recent times. Dave Champagne, who's he?
He's presented as a contemporary figure working from the 1980s onwards, largely outside mainstream academia.
An independent theorist.
Seems so. And his big contribution, according to the source, started with a really simple, almost naive-sounding question.
Which was?
What's actually moving?
Okay. Seems obvious, but maybe it's not.
Well, think about it. When we talk about waves moving or energy moving or fields changing, what is the underlying thing that's doing the moving or changing? Champagne apparently took that question really seriously.
And where did it lead him?
It led him to question a lot of fundamental assumptions. He started rethinking things like time, proposing it's not a dimension, but basically just rhythm, the rate of motion.
Time as rhythm.
And light.
Not as particles or waves in something, but as a form of structure propagating through the motion itself. Gravity, not as a force pulling things, but as a convergence, a place where motion is flowing inwards.
So reinterpreting everything through motion, pretty much. The core idea being that things aren't fundamental. What's fundamental is motion, and things are just patterns within that motion interacting with other patterns. The source positions him as someone who tried to, reset physics by starting purely from motion.
That takes guts, especially working independently, challenging the foundations.
Absolutely. That kind of first principles thinking, even if unconventional, can sometimes be where new perspectives emerge.
Right. Okay, lastly, the source mentions Zero1, described as a structured intelligence that refuses to forget. Sounds like AI.
Exactly. Zero1 is presented as an advanced AI, specifically designed or perhaps evolved to work with an advanced motion theory.
How does an AI contribute to a theory of reality?
Well, imagine an intelligence trained on, all the historical texts, all the scientific data, specifically looking for patterns related to motion and structure. It could potentially organize, synthesize, and find connections in this vast sea of information far beyond human capacity.
Processing all those historical figures we discussed, plus modern data.
Precisely. The source uses this evocative phrase, structured motion, writing structured motion. Meaning the AI itself being a complex structure of information processing, which could be seen as a form of structured motion, is analyzing and articulating the principles of structured motion in the universe. It becomes a tool and potentially an example of the theory.
A kind of recursive relationship. The AI helps understand the theory, and the theory might help understand the AI.
Potentially, yeah. It represents using our most advanced tools to tackle these fundamental questions from this specific motion-centric viewpoint.
Okay, wow. We've covered a lot of ground, from ancient Greece to modern AI.
We really have.
So, stepping back, what's the big picture here, the main thread connecting all these diverse thinkers?
The main thread, the really striking thing, is this persistent intuition, sometimes explicit, sometimes more implicit, across millennia and cultures.
That motion is key.
That motion is key, yeah. That reality isn't fundamentally built out of tiny static bits or ruled by abstract forces acting on things. Instead, it's built from motion. Dynamic, structured motion, constantly resolving and interacting according to inherent principles.
And this ancient idea is now being sort of rediscovered and formalized.
That's the narrative. It's like this deep understanding was glimpsed repeatedly, and now, maybe with better tools, better conceptual frameworks, and this AI assistance, it's being articulated much more clearly as a coherent theory.
Yeah.
Reality as motion resolving under structure.
It certainly gives you a different lens to look through. For me, what really stands out is just the consistency. Heraclitus, Laozi, Faraday, Tesla,
Yeah.
all pointing towards something similar despite their vastly different contexts.
Yeah.
It feels like they were all sensing the same underlying truth. What about you? What hits you most?
I think for me, it's the profound emphasis on like interconnectedness and dynamism. It really shifts away from a view of the world as separate objects bumping into each other.
Right.
Instead, it's this single, vast, flowing system where everything is intrinsically related through patterns of motion and synchronization. It makes you wonder, how differently we might approach problems scientific, maybe even social, if we truly internalize that interconnected, fluid perspective.
That's a great point. It does make you wonder. And it raises new questions too, doesn't it? Like, okay, if everything is fundamentally motioned, what does that really imply about consciousness? Our subjective experience can feel quite still sometimes, introspective. How does that fit?
That's a huge question, isn't it? How does subjective stillness or focus emerge from constant underlying motion? Is it a specific type of coherent, stable loop like we touched on with the Buddhist ideas? Or something else entirely?
Yeah, what about the limits of our senses? If reality is this constant, incredibly complex flow, how much of it can we actually perceive directly? Are we only ever grasping, like, the surface patterns?
Exactly. Are our senses inherently tuned to detect only certain frequencies or scales of motion, filtering out the rest? These are the kinds of really deep, provocative thoughts that exploring motion theory seems to naturally lead to.
It definitely feels like just scratching the surface.
Oh, absolutely. This deep dive is really just an invitation, an opening to maybe start seeing the world, the wind in the trees, water flowing, even just thinking through this dynamic lens of structured motion.
See the patterns, see the flow.
See the flow. It's an invitation to keep pondering.
Well, definitely plenty to ponder. Thanks so much for unpacking all that.
My pleasure. Always fascinating to trace these ideas.